So good morning, everybody, or good afternoon, good evening, depending on your time. So welcome to the Hackathon in 2024. My name is Bernard, and I will be presenting today's topic with my colleague Michele. So he's a PhD in Trento, also working for g.tec. We're involved in Unity development for the Unicorn SDK. Yeah. So today, we are going to provide the guidelines on how do we build game with the Unicorn Unity package. And in the first place, I would like everybody, if you're involved in the game project for sure, think about what would you like to create in the first place, and how would you like to link your stimulation pattern to your game with the BCI. And in the coming 24 hours, you will build your own game for sure. Then you have to integrate your game with the BCI command, and then deploy your game, run in real time. And potentially, if you want to have a nice presentation, you can film a video of your game and then play it in front of the judges. So that would be an easier way. So let's have fun. So in terms of games, like do you want to create a completely new BCI games? Like this is the game that we created before by Michele and I in the hackathon. Yeah, so it's the integration of the game with the BCI logic together. Here's the training. Yeah, it's the freshman stimulations. Yeah. Or do you want to basically use the old traditional game like Tetris or Pac-Man, but you want to add some extra power to the game? So here we have our stimulations, and with the Pac-Man and the ghost running around. And if you select the freshman stimuli associated with a particular ghost, you will be able to freeze them from moving around, and then you will be able to actually collect the dot around it. Yeah. Or do you want to actually create a game that is for the people in need? So this is the game that I created before as an ADHD game for the puzzles for the ADHD children. So it's a way we created hopefully to provide a way for ADHD children to improve their focus. So there are different way you can build a game with different purpose. Yeah. And for now, just to think about what we'd like to create. And later on, we will show you the toolkit that we're going to use in detail. So we are going to use a Unicorn Unity package. It's actually a Unicorn development kit SDK for BCI applications. At the moment, we are supporting event-related potential. So everything like signal processing, like you can embed the stimulations, everything game logic together in one single applications in Unity, and deploy an executable, window executable at the end, and so that you can play around and check the performance. We're actually using, as I said, like visual evoke potential. There are different way to do it, but I'm not going to talk about more in detail. But if you have a very single stimulations, you have the response called ERP. If you have a stimulation patterns as a specific coming as a specific frequency, where the response is happening in frequency domain called the SSVEP. And if you have representing the stimulations modulated by binary code, and it will elicit a visual evoke potential called the CVEP, the code-based response. And in the coming hackathon, you will focus on the ERP side. Yeah. So it's the protocol that we are using is with a high information transfer rate, and you don't have to do any task while focusing on the stimulation. The accuracy is pretty high, and the BCI selection is continuous. And there are some prerequisites that is needed for this package. At the moment of time, we are using Unity 2020.free. Like we don't force everybody to use a particular version, but yeah, this is recommended. And we support Windows 10 and Windows 11. We also need a Unicorn license for the Unicorn Unity package. And if you would like to use the Unicorn Unity package, please send us an email with your name, and then we will grant you a license for it. And where do we find a Unicorn Unity package? It's actually inside the Unicorn suite. I will show you later in the video tutorial. And also, in case if you want to directly download, later you will be able to access via the GitHub link. But I think Martin will also send you the link in the comment sections. So, how do we set up a Unicorn Unity project? The Unity project. So first, what you need is you have to have the Unicorn suite installed. So first of all, like please configure, like as Martin said, please follow the instructions on the user manual, configure the Bluetooth correctly. And if everything is fine, you will see this green logo saying that you have a correct Bluetooth adapter using. And search for your Unicorn device. Next is be sure that you have at least the Unicorn Unity license. And if you want to visualize your data in real time to check like the signal quality before running the Unicorn Unity game, it's recommended also you ask for a Unicorn Recorder license so that you can inspect your data beforehand. So for the dev tool, if you want to have a Unicorn Unity package, you can go to the dev tools here. There are different APIs, but go to this part. So usually there will be a download button, and then there's a play button for installation. And afterwards, you will be able to open a Unicorn Unity package with this open button. And you will see that the installation path together with the package in a specific location. Then you copy this location. Yeah. The next step is you have to open your Unity environment. You create a new, first of all, make sure that you're using the correct Unity version. You create a new Unity project with the 3D template. Create some names for your project. Define your locations of your project folder. And then Unity will create a project for you. Afterwards, you will have a scene like this with nothing in the assets. Remember, we copied the path for the Unicorn Unity package. Then we go to Assets, Import Package, Custom Package. Yeah. Then we go to this path, look for the Unicorn Unity DLL, and then we open it. Make sure that you check everything that it's inside the Unicorn Unity package, and then import the Unity package into this Unity project, and then you will see the SS folder with this few components. And what we're interested in is the g.tec folder. And obviously in the Unity interface, we have different components for testing, but we have already provided a tutorial scene for everybody to kickstart. So you can directly modify the scene here to build your own game. You can create some new objects and obstacle. Yeah. And the whole scenario will be described by Michele in the later stage. And in the end, if you want to build a game, it's very easy. You just go to the game. You just go to the build, and then you add an open scene, which is the one that you have already opened in the background, and you click the build button to build the to deploy your game as a release build, and you run it. Yeah. So, and let me go back to my presentation. Yeah. So the last thing I want to talk about is when you're designing your game, you have to understand what is the constraint of the particular BCI paradigm. For visual evoke potential, it's not very ideal to have a lot of class in the same screen, especially when your object is moving around, then it's even harder to focus. And also, if you really have to go for a lot of class, please be sure that you increase the confidence interval in the game by modifying the selection threshold. Michaela will also show it to you. So this will provide a more robust classification with less false positive. And try to gamify the whole calibration procedure in the training, and use the combination of like BCI commands and standard input, like you showed what we have in with Leo's playing the game. Yeah. So in the meantime, I will pass the stage to Michaela, so he will show you guys how we can actually configure the Unity scenario in real time. Michaela?
Thank you, Bernard. Amazing, you already introduced all things I need. Okay, I will share my screen. Yeah, give me a sec. Okay, do you see my screen?
Yes, I see your screen.
Good. So I'll take over from where Bernard left. So either if you start from the tutorial scene or from a new scene, the first thing you do is probably dragging from the prefab folder of the Unity interface, the BCI system. So this prefab already contains everything you need to make your BCI. So if I open it, you see there is a BCI manager, there is a flash controller, there is a BCI controller, which is basically the UI. So flash controller is the stimulation controller, and BCI controller is just these buttons that you see here on the screen. Then we have a BCI configuration. This is where you set up everything in the BCI. And then a signal quality configuration. This is already pre-configured, so you don't really have to worry about that. After you drag into your scene, it's time to build something. So I created 5 objects. These Unity objects are just 3D cubes, so nothing special here. And they only have this component. So if it's a 2D object, you have to add the 2D version. So it's called Flash Object 2D or 3D, up to you. So you can just look for it, Flash Object, and you say 2D, 3D. Okay. And I created 5 of those. And later we will go through all these settings. I also want to show you that I created 5 cubes that I will use to show the interaction with the BCI. So these cubes are just standard cubes. They have nothing special. They just only have this label that tells something when you focus on them. And then we have the flash controller. So the first thing you need to do is to add your objects, your BCI neurofeedback targets to the flash controller. Okay. In the flash controller, one of these is going to be the one on which you do the training or calibration. In my case, I decided to pick the center one, which is this one. And then the others are application objects. You can reuse the same one that you use for training also as application objects, okay? At this point, there are some things to check into the configuration. So the class, for example, cannot be the same for 2 objects. So you should put a different class for each. In my case, I have 4, 5, 2, 1, 3. Okay. Then you can select an object as feedback target. In my case, there is one pre-built into the Unity interface, is the green circle that you see here. So this feedback target activates when you're focusing on the object in application mode. So if you don't put it, nothing is going to show up, but it's useful to have it. Then you can also select which material is going to be for the flashing. So in my case, I picked from our implementation, the black one. So flash material and dark material are this one. But you can have different materials for each object. So you're not forced to use the same material for every of them. You can use one yellow, one blue. Of course, some can work better than others if there is high contrast in your application. So keep that in mind. And then the other option is the activation time. So it's how long it takes of continuous focusing to activate this object. Okay, so in my case, I decided to put from left to right, 1, and then 2, and then we have the center has 3 seconds, right? So there's like an increasing difficulty in selecting those objects. I also did something. I connected my cubes, the color cubes, each one to one object in this way. So I created a callback when the neurofeedback is activated to activate this object, because like in the tutorial, they will not be visible. Okay, so for each of them, I connected that during the unactivated event, when you're focusing, the object is visible, and on the release, when it's deactivated, the object becomes invisible. Okay, so now we're going to test this out, and let's have a look. Also, in when you're developing, you can use a simulator. So there is a simulator for the device, which is essential for starting the entire BCI. Okay, give it a moment. Unity can be slow if you have a lot of programs open. And okay, so in this case, I connect any of the 0 devices is a simulated device. So just pick one of those and you can connect. And you see already that you should get some fake signal quality. Okay. And if you start the training, make sure that vsync is activated. This is really important for the BCI, because if vsync is not activated and your frame rate goes up, is gonna desynchronize the triggers, so the classifier is not gonna work. Also, when testing, is fine to use the editor, but it's always better to build your application, because the editor is a virtual machine and has lower performance than your computer. So if you build and run, is better than testing in the editor. That affects the BCI if your computer has frame drops. Okay, so it's important that you also remember about that. So now I think I put in my configuration 60 trials, which means 60 flashing of the object. Exactly. So after 60 flashing, the training will be over and I should receive a response from the classifier. The response is this color here, right? So red means the classifier is not good. Yellow means that the accuracy is over 80%, and green means that the accuracy is over 90%. So always try to get green if you can. Yellow is also fine. Red, you cannot at all start the application. I mean, you can start it, but you don't get output. When you start the application, all the objects start flashing, okay, following a sequence. Now, there are also some things to test these objects. Application is on. On the BCI controller, you have this input simulator, okay? And you can also decide how long to simulate the input. Right now, it's 1 second, so I can hold the first object and activate it with my mouse. Make sure you have also an event system in the scene. If you don't have, this is the standard event system from Unity. No need to do anything, just put it into the scene. But if you don't have it, you're not gonna have the click input. And if I try to activate the second object, I also can, but the third one is not, because it's already, like, I get the feedback that I'm focusing on it, but I don't show the cube, right? The cube only shows if the duration is over the threshold that we decided. So I think it was 3 seconds there. Yes, so I can have it with 3 seconds. If I go above 4, I can get this one, but not this one. This one is 5 seconds. Okay, so you get the idea. You can build the entire game without connecting the device and test all the dynamics. Of course, it's better if every now and then you test with the real device and the person. But in the meantime, since you will be working in 4, 5, 8 people on the same project, everybody can contribute to the development. This is good for games, it's good for artistic projects. That's up to you. I will go just quickly on the BCI configuration to have a look, because here is where you set the number of training trials. So you have minimum 30, maximum 200, really never use 200, but 100 sometimes can be good, especially if you have more classes. Also, the number of classes has a minimum of 3, but you don't need to have 3 objects. In the application, you can also have 1 or 2, but minimum is 3 for the training. And maximum is 60, but I don't recommend using 60 unless you're building some kind of speller. And this is the duration of the flashing. So if you lower it, it's going to be faster. If you increase it, it's going to be slower. So this is super fast. This is half a second of flash on, and then the off time is calculated automatically. So you just control the on time. The confidence, as Bernard said, if you have few classes, keep it low. If you have many classes, keep it high. That's going to impact on the performance of the BCI. You can, by clicking here, you can save the data of the session in a CSV file. It is going to be in the folder of the project, so you can analyze the data later. You can do other stuff with this data. And then you have advanced settings, which is really something you should not worry about. So it's just changing how you sync and some options of the filter. So it's really not relevant for this challenge. And if you want, you also have some callbacks on the BCI manager. So these callbacks are, so the standard configuration here is already prepared to work. Okay, so you don't need to do anything, but you necessarily have one simulation pipeline and one signal quality pipeline. Then you can enable debug messages if you want to have more information in the Unity debugger. Here we already configure all the components connected together so that when there is a callback from the BCI manager, which is basically the command center of the BCI, all the components are updated. For example, when there is a new signal quality information, we are updating the component, this one, the signal quality bar, but you can connect your own component. So you want to do something when the signal quality changes, you want to make it like the environment changes color, or there is some shaky effect, you can do that. You just connect your component and update it. If you want to see how it works, you can easily open the scripts of these components, which are in the BCI controller. So you can totally modify the UI, you can totally modify the buttons, you can go in and modify the signal quality components. You can also extend Flash objects. So if you want to create your specific animation when the object is activated or deactivated, you can extend this class into a new script, and you can override the methods and do whatever you want. In the BCI manager, it's also important that you can, when you get data. So there is information about losing data, and there is also information about new data. So you can subscribe to this event and get a stream of data out of Unity if you want. Okay, you subscribe to this event, you redirect the data somewhere, so in one of your scripts, and then you can use other communication protocols like LSL or OSC to send data outside of Unity if you want to do something more complex, so outside of the Unity environment, but using a Unity interface. I think it's all on my side. So if you have any questions, please.
Thank you, Michele.
Thank you, Michele. Just got a lot of visitors for the hackathon here, so it's very loud and busy. Maybe that's a little bit disturbing. Somebody was asking Michele if the Unity toolbox has only P300 and EIPs or also something else inside.
So at the moment for this hackathon, we decided to leave the P300 because it's the most tested and stable. So we are still fixing some stuff on the CVEP. But if you continue using it after the hackathon, there will be more stimulation paradigms available.
Any other questions for the moment? Otherwise, thank you very much.